Okay, welcome back. So unfortunately, my original video on this got corrupted, so I'm re-recording this really quickly. But I just wanted to go over an example problem regarding dimensional analysis with atoms to moles. So I've been seeing this post float around social media for a few weeks now, and I think a lot of people just kind of resonate with just the general feeling of despair that comes with chemistry or just education as a whole. um, but the question itself is actually pretty simple. So I just really quickly wanted to go over how to solve it. Um, so a few of the key components here that we're going to talk about real quick before we hop in is this word right here, moles. So a mole is just kind of it's a unit of the amount of a substance. It's just a fundamental unit, an SI unit, and it's related to this constant called Avogadro's number, which is 6.022 times 10 to the 23rd. And that basically says in 1 mole of substance, you will have this many of a given particle. It could be atoms, it could be molecules, it could be ions. You will always have that many particles within 1 mole of a substance. And this is important because helps us really simplify down when we're talking about I guess when we're talking about chemical reactions. We can think of it on a molar basis, um, where we you know it you could say 1 mole of one substance reacting with 1 mole of another substance will create 1 mole of a third substance. It's a very, very simple way to think about chemical reactions versus doing it on a mass basis. And that Avogadro's number is actually going to be pretty important for how we decide to solve this. So we'll go ahead and do that real quick. And if you're confused about anything regarding dimensional analysis, we posted a video to that quickly runs through an example problem on dimensional analysis prior to this. So feel free to watch that or leave any comments with any questions, and we'll try and answer the best we can. So our question here is we want to convert 5.3 times 10 to the 23rd atoms of methane to moles of methane. So this is a very, very simple dimensional analysis problem where we're going to go from atoms. If I can write, we can go from atoms to moles. It's a very, very simple way to do that. So we say we have 5.3 times 10 to the 23rd atoms of methane, right? So the idea behind dimensional analysis is treating the units themselves as their own variable. So if we want to cancel this out, we'll say for every mole of methane, which was what we're trying to find moles up here, we need to have Avogadro's number, which if you remember was 6.022 times 10 to the 23rd atoms, or any other particle, but in this case we're talking about atoms, so we'll say atoms. So then we go ahead and set this up where we just stick this in the denominator. So atoms of let's say methane, and then it just becomes a pretty simple simplification and division problem. So we can cancel out atoms of methane with atoms of methane. And what we're left with is, we come down a little bit, we have 5.3 times 10 to the 23rd over 6.022 times 10 to the 23rd moles of methane. And that's pretty much it. This is doing the math on this. This will be 0.88 moles. So about 9/10 of a mole of methane, and that's the problem, right?